For today's webinar, we are going to continue on with our two-part series that I started last week, this being part two, on a small project where I 3D scanned a portion of a coffee maker, and we are going to design a new part to condense an assembly down into just a component of the assembly of the coffee maker. And today's focus will be primarily on the design aspect, where last week we focused on the scanning and data processing on the front end. So with that, we'll go ahead and jump over here. So those of you that missed last week's webinar, I will keep the PowerPoint short because this will definitely be a typical length that's become a norm around here, where it's going to be probably a good 40 minutes of modeling here, and where we're going to take this part here down below and condense it down to just this part because the entire coffee maker broke, but we want to salvage the frother portion of it. And this was a family member of mine that proposed this concept, and I said, hey, let's go ahead and make it part of my webinar series. So today we're going to continue on with that process. Let's go ahead and jump right in. So as usual, we always start out by just going over this slide, and I will pare it down. As a lot of people are watching my webinar on a regular basis, I know that going over this slide could take a few minutes, and it's redundant for you, but I just wanted to make sure that anybody that's watching this for the first time understands what DesignX is really quick before we dive into the application. But DesignX is this software right here. It's the software that we use. It is a software that can work with 3D scan data from a variety of different inputs from different devices like these over here on this side, from structured light scanners to laser to handheld laser structured light scanners, time of flight scanners, CT scanners even, all kinds of different devices. We're creating this type of data, and people were trying to load it inside of CAD, and we're struggling a lot because CAD wasn't designed for this type of information. Enter DesignX. We create this software that is a parametric CAD modeling kernel with a 3D scan kernel all in one space, right? So then we take this data, do the heavy lifting, and then we extract model information and output it in different sources like you see on the right-hand side, whether these are the high-level outputs. CAD is the primary, but we also go straight to CNC packages or straight to additive technologies out in the market. So that's what this DesignX product is all about. Grabbing that scan data, recreating or reverse engineering that object, and getting it out to whatever is going to produce that manufactured model. So with that, we'll go ahead and jump right into the DesignX portion. So here is where we left off on the last webinar. We went ahead, and let me just turn my regions off. We scanned all the individual parts. So here's the main part, and then I scanned just this little back cover. So if you can see here, I'll turn off the main part on and off, and I separated that out and scanned just that cover. The inside, the bottom, and the reason why is the bottom actually has a piece that's important to note what's there too. And then this piece right here. So the frother obviously sits right on this base, and it makes two different electrical connections there. And then most of the components of the frother actually in it itself. So this is really just providing the power to that unit, and then it's kind of a self-contained section. So really all we did is we disconnected everything else, and we have the power coming in. It splits off to go to the main coffee maker and then splits off to go here. So all I had to do is take this piece, these electrical connections, and connect them to the cord and put that on the base of the frother, and then it continues to work. So that is just kind of a summary of the project there. But now we need to print a part. So we are going to reuse this piece right here because it's an electrical component with some extra stuff inside. Yes, we could print it. We could go crazy here. But in this instance, all we really need to do is recycle that part and design something that fits around this to then create a printable piece. So let's go ahead and get started here. So let's turn on the whole part, and you see here the place we're going to start is going ahead and creating the outer puck that we are going to work with. So you can see here that I scanned the entire assembly, but for my basic start, I'm going to look at, here we go, inside. Basically, this component is the whole thing, taking everything apart and scanning the inside. So we'll go ahead and start with this and then kind of model the basic puck and go from there. So I'll go ahead and start out by creating a second plane. You see here I'm just averaging two planes together. Little side note, you can click on two planes. This is a CAD trick for most of the parametric CAD softwares, right? Select those two planes and create an average plane between them. And I already had an axis there that's coincident with those. So now I can go ahead and start out by revolving a axis around. Now you'll notice right out of the gate, if I look down here, I'm going to base everything off this center axis right there. But you'll notice that this radius is not coincident with this one, because look at this distance here, that distance there, and that distance there. I think it's quite obvious from here to there that the center axis for that is probably somewhere over here. I'm going to deviate from this design. I am just going to select this and revolve that around and go from there. So, and to prove that, I will come over to rotational mode, select the central axis, and select it again, and select my base plane as this. You'll see as I rotate back and forth, I'll just type in 0 here. The other thing you can do is silhouette it, and you'll be able to visualize what I'm talking about here. So if I just move that there, and then let's just change it to like 30 degrees. Now look at what happens. This is how I know that those axes are not in the same place, because when I cut just that slice through there and it flattens and silhouettes all that back to a plane, this is the actual right here of where I am cutting, and then this is all the way out there on the edge, right? So instead of silhouetting it, I'm just going to type in 0 and cut one section and turn off my mesh and zoom in, and we will go ahead and start drawing this cross section. So we'll start out by just selecting this, create an arc there, rough out some, click on that, create a line, click on here, create a line. I'm going to go ahead and add those two together like so. Then we can come over here, rough that in. A line here, snap this. And while we're at it, we're going to go ahead and draw the inside as well. Right, so we'll come in and fit that line and that line. Oops. Didn't want to do that one. We'll keep that, this, and actually I'm going to make that level here. You'll see here in a minute. And let's just go ahead and trim some stuff together and simplify this down, because I'll show what I'm thinking next here. Let's go ahead and draw one of the shortcuts for drawing a line on a tangent line without having to apply tangent is use the inference lines, like what happens here. So I just use the inference line to make a tangent line, right? And then I come back and I just take that line and make it vertical. This is just a design choice that I'm making. And then if that happens, go ahead and make that fixed, right? And then come back and make that vertical. And here you do a shift select between those two and make that tangent. And let's just make sure everything is good to go by doing a corner trim here. And actually, if we just, I love this extend tool. This is different. It's not the extend, but it's a variation of extend. That's why I say it. Like, it could honestly be a component of that tool. But you see, this extend is just resize, where you click and drag something, and you drag it out. And you see here that I wasn't going to be able to trim that line with that other one. But here's a design decision that I'm going to make on the fly, because I've already done this once. So I'll go ahead and talk about it at the moment. But when you print something additive, you see that this is not horizontal. And because I printed this, if I revolve this, this is going to become a cone. And one, it's not necessary that this be a cone, that this is a cone. Two, when I print it, I have layer line stair steps on this, and it just wasn't very good looking. So what I ended up doing after I printed it once, I decided to go ahead and come in, roll back through my history, and make this, and just snap that there, make that horizontal. So yes, I'm adding material and making that completely flat, but it eliminated that stair step, because my printer isn't a professional printer, right? I just have a consumer one here at home that I print stuff for with my kids and stuff. So if I make that horizontal, that just makes it easier. And the same thing here for this. Making this horizontal actually takes those layer lines away that I don't need. Now I want that taper down because there's a piece that fits here. By the way, you can witness, if I just turn this on and turn that off, we can see what we're getting ready to do here, right? Because I have my assembly. This is what's so nice, is I have my assembly. I can turn on and off components and visualize where I'm at. And then that also makes it so I can just come in here and extend that. We can always resize this later. But just explaining some of my logic. And since I already completed the project and I'm doing this for the video to show everyone how this works, I have the hindsight is 2020, so I can explain some stuff that I discovered along the way, which is great. When I have a printer, I can just print it out, fit check apart, and then go, oh, I want to do this way instead, and go from there. Now I can offset these if I want to. You see here, if I click this and hit offset, and I won't take as long with every single one of these cross sections, because this webinar would end up being like 19 hours long. But we will speed up the process as I get going here, and I will shortcut some of this. I figured I would just show what I have here, and we'll go a little in depth as to the original sketch, and we'll go from there. So here we go. Go ahead and trim. Oops, trim that. And keep on sketching. Now, if I was reverse engineering this to the nth degree, right, I would actually offset all of it, whatever. But just for the sake of what I'm doing here, and you know, expedience here, actually, just take that and this. I'm just gonna draw it and not worry about constraining every little thing here. You know what I mean. That way, I don't waste everybody's time. I can just go a little bit faster and show the overall concept, because when I was designing it, yes, I spent more time just dimensioning everything out exactly, making things horizontal, vertical, putting dimensions on things, all of that stuff. And now we have that. Now DX likes it if you like have something within the sketch. SolidWorks is this way as well, right? So I tend to, as just a rule, have like a axis in that sketch, um, because it just makes it easier. And there we go. So we modeled that. We got started there, and we are off and running. So the first thing is, we went ahead and revolved it. Now let's just take a look at the other components here and see what we need to do next. All right, so let's go ahead and model these tabs here. In order to model these tabs, look at, it's a little off for some reason. I don't know why. Maybe it's the indexing. I bet you it's the indexing of the frother, because those tabs kind of help index, making sure the I think the power or the positive and negative, I don't know, are aligned properly. But what I'm going to go ahead and do, there's a bunch of different ways we can do this, but I'm going to go ahead and say I want to do a rotation plane, and we'll just look at it from the top, and I'll just drag it over and visualize it from the top, and then you can hit normal 2 and just use there we go. And we got 12 and a half. Let's just type in 13 here. I think 13 degrees ish. That works. These don't have to be super, super accurate, by the way. So I'm just going to use that and do another sketch rotational. And with this one, we will actually silhouette it. Let's silhouette this. Oh, actually, we got to make sure we select our rotation axis. There we go. And silhouette this 20 degrees. There we go. And it is important to note that you can, like, if you want to just simplify your view, you can drag these nodes around to just what you're trying to work with here. Limit it that way. So now we'll just turn off the mesh and come over to line segment. And again, I'm going fast. And we'll just, there we go. Trim all these together. Turn that on. And I will do mid-plane, 10 degrees, drag it out like so. And again, these don't have to be super accurate. I could add draft. I'm not going to bother with draft on it because I already know that it works without the tolerances are there. So now that we have that, we can go over and just do a circular pattern of this body. Actually, by default, the latest version of DX merges. So you see here now I went ahead and unmerged it so then I can say circular pattern, this body about this axis. And we will just change it to 2. Hit OK. And then if we want to go ahead and Boolean that in, we can. And if you want to go ahead and apply fillets to it at this point, you can too as well. And sometimes I use these face fillets because it's faster than selecting edges. It all depends on what you're trying to fillet. If I'm just going to go ahead and throw the same one on the entire thing, then I will do it that way. So let's go ahead and save and move on to the next feature. So now we'll just turn on some components here. This cover has to come in and mount. And there's a couple things it interfaces with. It interfaces with these posts right there. Obviously the top face. And then the other thing is it interfaces with, we can go ahead and cut this out next. So you'll see what I'm going to do here in a second. But I'm going to go ahead and grab this face. And let's go ahead right now. You see here that I modeled this face coincident. But what I want to do is actually, there is no feet on this right now. I could mount feet. Actually, that's what I did with the one that I printed out, is I bought these little rubber feet and screwed them in. But for what we're going to do here, just to show how the history works, I can come over and say edit sketch, go normal 2, and extend this down to wherever I want it to go. And then if I wanted to dimension it, I could. That works. Now, if I get out, you see that it's extended past. And I'm going to now grab that face, and we are going to make all of this solid from here and this extrusion down. So you'll see what I mean, where I will come in, and we're going to now use this sketch instead, the bottom. We're going to use this as my base plane right here and intersect there. Okay, that looks good. And we're just going to draw the interior shape here. So turn off the other two. And this is all we're going to draw. The circle here. Zoom in. And this circle here. Then we'll do a circular pattern there. And trim that together. And we will do some fillets there too here. So we'll use the first one. We'll figure out our dimension here. And it's set for specific values. So let's go ahead and click and drag. It looks like about a 2mm fillet will work for me. And we can go ahead and apply a 2mm fillet. Now, we're going to marry that to the outer shape here. So I will draw another circle and just draw in the material there, like so. And we'll turn on this, and I'm going to say I want to extrude this sketch right here up to body. And merge it with it. So there we go. We are cooking. So now, turn on the meshes. Turn off the solid real quick. Let's find the right mesh. This one here has this face right there. So now we'll turn on the CAD body and click that face and say that I want to put a mesh sketch on it and bump that down. And I want to intersect that and just find where that circle is. So we're using a separate component there, right, to another component to find where this circle is. And if I want to, I can window in. This is just a little tweak here, little hack. If you want to go fast, do fast modeling, I can make this a region. If I don't want to measure this and figure out like the depth, I can. This is a quick way to do it. So I could say I want to extrude that sketch. This sketch right here. I want to extrude it up to region. And these regions have different options. You can say it could, if you say up to region fit surface, it's going to fit a surface to that and then trim my region with it. I could just say up to the average distance of that region. So it's going to go down and average out a plane. Now, I didn't change the operator to cut. So we want to make sure that it cuts. Now we turn on my solid So you see there, it just averaged to the mesh and created that. Perfect. Now we're going to come in here and model the mount's direction. See this right here. This interferes with this right here. So I'm going to model a envelope that goes around that and just give that area clearance. And then we're going to put a mount here on the back where the electrical cord goes through. So to do that, one of the things we're going to do is we'll just find that direction. So I'm going to grab this and I think it's this one. Yep. If I just look at it there and calculate a vector, intersect the two planes, create a vector like that. And just take both of those, create a point. So I'm going to now create that plane. It's perpendicular. Actually, I probably could have done that a different way, but sometimes the fastest way to get you where you're going is the fastest way to get it done, right? So this, and I'm going to come along here, and I just want to know the envelope size of that, right? And now hit OK. And I'm going to flip my direction, turn off the solid, and I'm just going to draw a centered rectangle. Like so. And then I'll turn this on. And if I want to, I can also grab this here, do a convert entities, and let's go back to normal and see where I drew that. Yeah. Just let that floor define with that convert entities. And let's just trim this together here. And go back to corner trim. And obviously I would dimension this all out. The other thing is, let's go ahead and turn that solid on and see how high I went. That's fine. And turn the solid off, turn this on. Let's go ahead and get out of this and hit extrude. The nice thing about this is it's all history based, right? So I'm just going to give it some extra depth because this is I'm just going to model a cavity, give it some extra depth. I can turn on the solid and see how far I'm going. That far is good with me. And really all I'm doing is I'm going far enough that the wires have enough time to bend and exit. And I'm just going to say insert just so I can visualize it first. I think we are good to go there, so I'll just change it to cut. I just wanted to visualize it before I go ahead and cut it. And I'm going to come over here, just do a regular mesh sketch. And here's another little trick here. You can turn on hidden line, and I can grab these and do a convert entities. I only selected one. Now just change it back to, so what I'm doing now is if I just come to the top, and this is actually just from experience since I already designed this once. And we will do convert entities on this. And turn the solid off. I'm just creating a little cutting tool. Like that. And basically this is just from experience from when I designed it, that I am going to cut this away. Like that. And the reason why is that just removes extra overhang for my print that I don't want extra overhang that I um, don't want to use. Right. So leaving that in there just had more supports that would be when I print. So that's why I wanted to go ahead and remove that. So now let's go ahead and just draw where I want that electrical connection to be. So I can do another centered rectangle. And again, normally I will come in and dimension all of this out. And for this one, it probably is good to go ahead and dimension it somewhat out because I measured my chord and I actually designed it so the chord has a slight interference fit to where I slide the chord in and I didn't put any strain relief or anything. The chord just had an interference fit with the printed part. So rather than purchasing some sort of strain relief connector, you see here, so I went ahead and created that. So now we'll go ahead and extrude that, cut it. I was wondering here on the fly, let's just do something here. I'm going to throw a plane out here, go normal to that. Actually, before we do that, on this, let's go ahead and apply those fillets. And I think I did something around here. Like that. Then come back over here. And to convert entities, offset. And I just want to try something kind of on the fly here. This is another way of doing this. Maybe select this, emboss to this surface. So it looks like I might have to emboss it before I do the cut. So what I can do here, just get out of there and change this from the cut insert. Now you have to reassign your fillets there. But I can still just turn that sucker off and come over and make this construction geometry. There we go. Now, come back over to emboss. I just have to do it in 2 steps. I was just trying to get a little aggressive there and see if I could do it up to, kind of out of order, honestly. And it did it sticking out to the normal of the surface. So I'm going to change it to pull direction, I believe is, there we go. That's what I'm talking about. And then I can just go ahead and boolean that other one away now. If I sat and thought about it, I'd probably figure out a quicker way to do it, or maybe with less steps. Like, again, sometimes the fastest way is just the most efficient because you're not spending a ton of time thinking about a way to do it. Unless I was going to make millions of these, then I would come up with a certain way to do it. So you see, I just noticed that I went a little too far with this. So I can come over here and edit that and come back. So for this next part, I'm going to go ahead and just turn these posts back on because you don't need to watch me model those two. They're very easy, simple things to do. But so I will just turn those bosses on. So there, just turned on the bosses. And now you see if I turn on the mount and turn off the inside there. So there's the mount. And somehow I did something here. So let me just double check that. Check that in a second. So what I think that is when I went up to surface, up to body here with this, is it this one? No. I did up to body on this. Let's just go blind and offset like, there we go. So now everything should be good to go. Because what happened is that one that I used, it went up to body, went down there, and then I patterned it around. So quick to figure out the issue there. So now I have this, everything's good to go. We are going to reuse this cover. So if you want to see the cover and how it fits, we can do a few different things here because we are pretty much done here now. But you can use the cross-section tool to see how that piece is going to fit with this piece, right? And how that piece is actually going to intersect with, see, that piece is going to push that up in to the assembly. And you can check your fit here and adjust tolerances. You see that the wires will have plenty of room. I already know. I switched out, I cut these off and I put new ones on and they flexed over just fine there. So there is the cross section of cutaway. So you can see the assembly. So now all I have to do is just turn this off. Is take this guy and print this out. Now I went ahead and added some fillets and stuff. We already covered that stuff. I can take this, and this is actually a popular question. If I want to create a mesh of this, I can come over to convert to mesh, click on that body, and you have two different options. You can do the basic slider. I usually just do that for quick parts around here, crank it to high and do that. But you can also come over to advanced and like dictate how it's going to create triangles by adjusting the chord length, max edge length, min edge length. For the majority of the time though, just doing this works just fine. And if I hide the solids and show the meshes but turn these two off and adjust the color here because it's just easier to see with the regular blue. Nice crisp polygon mesh that I can go ahead and hit print on and print it out and assemble those existing pieces, put the cord in, solder it up, and we are good to go. So yes, this was a long webinar, but I wanted to squeeze it into 2 instead of 3. So thank you everyone for joining us on this practical application. So the part is very simple, but really what this is showing is assembly modeling from assemblies of scans and how to use those within DesignX.